So I want to take, we had some good examples from that website, and the nice thing about using one of these examples is we can check our work. I'll show you what I mean. This red, you see how the red value is 233 in base 10? Well, it's E9, the first two digits in that hexadecimal code. So E9 should give us 233. So that'll be a nice way to check our work. I'm gonna copy, transcribe that E9 here. And when we convert to base 10, we just do what we've been doing with all these different base number systems, except now our place values are based on powers of 16. 16 to the 0 power is 1. Anything to the 0 power is 1. So no matter what base system you're using, there will always be a ones place for that reason. The next highest place value in hexadecimal will be the 16 to the first, or the 16's place, not the 10's place, the 16's place. And so if I have a 9 in the ones place, 9 ones are 9. If I have an E in the 16's place, E is 14. So that means I have 14 16's. 10 16's is 160, 4 16's is 64. 160 and 64 is 224. And if I have 224 and 9, I have 233 in base 10. That's what this said. The E9 was 233. Okay, I want to remember that 203 because I want to show you how to go the other way also. But before we do that, here, I'll put it up here so I don't forget, 203. Before we do that, account for the difference in the length of these numbers. Why is this hexadecimal number only 2 digits while this base 10 number is 3 digits? Pause and think about that. If I can represent a value as high as 15 with a single place value, then I don't need to go to the next highest place value as often. In the same way that if I can only represent as high as 1 in the extreme example of binary, I need to be moving up to higher and higher place values all the time to represent large numbers. And so there's a trade-off. I mean, I think dozenal is the best trade-off. Hexadecimal is not used because it's better than dozenal. It's used for a different reason. It's more compact than dozenal, but now you've got an A, B, C, D, E, and F mixed in with all your 0s through 9s. So you don't want to go too crazy with the base number system and have too many symbols, but it is nice to have your numbers compact, and that's why we can represent 233 in base 10 with only two digits in hexadecimal. We could go as high as 255 with a 2-digit hexadecimal number, because the 16 to the second power place value is 256. So we can go up to 255 with 2 digits. And that's why those RGB codes you see go from 0 to 255.